Hello everyone. In this video, we will discuss how to graph the sine and cosine functions that contains horizontal and vertical shifts. And also, we will graph the sine and cosine functions applying the concepts of amplitude and period. So first, let us consider again the graph of the basic sine function and the basic cosine function. So we shall highlight five important points on the graph of these basic functions, but these points will be located on the interval of x between or from 0 up to pi. So for the sine function, when x is equal to 0, the y value is equal to 0. So we have the origin as a point on the basic sine function. Now, if x is equal to pi over 2, then the value of the sine function is equal to positive 1. If x is equal to pi, the value of y is 0. If x is equal to 3 pi over 2, the value of y is negative 1. And when x is equal to 2 pi, the value of y is 0. So these 5 points are the highlighted points for the basic sine function, and these 5 points are actually important in determining the graph of the sine function, applying the amplitude period and the shifts. Now, for the basic cosine function, when x is equal to 0, the value of y is positive 1. When x is equal to pi over 2, the value of y is 0. When x is equal to pi, the value of y is negative 1. When x is equal to 3 pi over 2, the value of y is 0. And when x is equal to 2 pi, the value of y is positive 1. So these are the 5 points that we highlight for the basic cosine function. Now, let us consider the functions f of x equals a times sine of x, and the function g of x is equal to a times cosine of x. So if we will be applying these functions into the basic sine and cosine functions, in here we see that a is equal to 1, and also for the basic cosine function. Now, this a here is important in identifying the amplitude of the sine and cosine functions. So what is the amplitude? The amplitude of these given functions is defined as 1/2 of the absolute difference of the maximum and minimum values of the function. So if we will go back into the basic sine and cosine function, the maximum value is positive 1 and the minimum value of the function is negative 1. So if we are going to get the absolute difference of 1 and negative 1, that's going to be the absolute value of positive 2, which is 2. And then if we get half of this value or half of this absolute difference, the half is equal to 1, which is our amplitude. Now, the amplitude is denoted by the absolute value of A, where A is not equal to 0. Because if A is equal to 0, then our functions will just become f of x equals 0 or g of x is equal to 0. Now, the amplitude is also interpreted as 1/2 of the height of the graph. So if you notice here, the height of the graph is 2. So this height is equal to 2. And then if we get half of this, then we get 1 as half of 2, which is the amplitude of the sine and cosine functions, or the amplitude of the basic sine and basic cosine functions. Now, the amplitude can also be interpreted as a vertical stretch or vertical shrinking of the graph of the basic functions. So if we have the same functions, f of x equals a times sine x and g of x is equal to a times cosine of x. If the absolute value of a is higher than 1, then the graph of f and g is a vertical stretch of the basic sine or the basic cosine function. Now, if the absolute value of A is between 0 and 1, then the graphs of f and g is a vertical shrinking of the basic sine and basic cosine function. Now, if we will consider the following figures here, the figure at the left side has three graphs, the red, the black, and the green graphs. So these are graphs of the sine function, but the black graph is our basic sine function. Now, the green graph is represented by the equation g of x is equal to 2 times sine of x. So the amplitude of 2 sine of x is 2, which is higher than 1. So that means this graph or this black graph will be stretched outwards. So meaning we're going to pull this graph outward and then outward going up, and then we will pull this graph outward but going downward. So it's like a vertical stretch of the basic sine function. Now, if we consider the red graph, then the red graph has the equation h of x is equal to 1/2 sine of x. Then the effect of the amplitude of 1/2 would be a vertical shrinking of the black graph or a vertical shrinking of the basic sine function. So which means at this point, we're going to pull it inwards. Okay, and this point will be pulled inwards. That's why we get the red graph um, for amplitudes that are between 0 and 1. So same explanation for the basic cosine function and the other cosine functions that we have in this particular figure. Now, what happens if the value of A is negative? So if the value of A is negative, then the graph of A times sine x or A times cosine x is just a reflection of the graphs of the basic sine function and cosine function. So if you notice here, this is the graph of y is equal to negative sine of x. So in this case, A is equal to negative 1. So if we will get the absolute value of this A, the absolute value is 1, so the amplitude is 1. However, since A is negative, then we have to get the reflection of the graph of the basic cosine basic sine function. So this is the graph of the basic sine function. So the 5 important points that we highlighted earlier. So the black graph here represents the graph of the basic sine function. So if you notice, if we will reflect the black graph along the x-axis, then we get the red graph as the graph of y is equal to negative sine x. Okay, next. Now, let's have the concept of the period of sine and cosine. So this time, let's consider the functions f of x is equal to sine of b times x and g of x is equal to cosine of b times x. So the period is the length of the smallest interval that contains exactly one copy of the repeating pattern. So if you will consider again the graphs of the basic sine and basic cosine function, the period of these two functions is 2 pi. It's because the value of b here is 1. For both of these functions, the value of b is 1, and the period is denoted by 2 pi over the value of b, where b is not equal to 0. So if b is equal to 1, then 2 pi over b is equal to 2 pi over 1, which is equal to 2 pi. So from 0 going to 2 pi, we see one pattern or one pattern of the graphs of the basic sine and cosine function. Now, if we go beyond 0 and beyond 2 pi, then we expect that there will be another copy of this pattern. So which means if we are going to extend this x-axis going to 4 pi, then the interval from 2 pi to 4 pi will also contain this pattern of the graph of the basic sine function. That is also similar for the cosine function. So if we extend the x-axis going to 4 pi, the graph of the basic cosine function will be replicated between 2 pi and 4 pi. Now, whenever we graph a sine and cosine function, having a period different to 2 pi, then we need to get the labels of the x-axis or the labels of the x-coordinates of the 5 highlighted points earlier, for both sine and cosine functions. So before that, the period can also be interpreted as a horizontal stretching or horizontal shrinking of the graph. So when does horizontal shrinking and horizontal stretching happens? So if we consider again the function f of x equals sine of dx and g of x equal to cosine of dx, if the value of b is higher than 1, then the graph of f and g is a horizontal shrink of the basic sine and basic cosine function. Now, if b is between 0 and 1, then the graph of the sine dx and cosine dx is a horizontal stretching of the basic sine and basic cosine function. So let's consider the following figure. So this one is the basic sine function. Now, if we want to graph y is equal to sine of x over 2, then that means b is equal to 1 half, which means that the period for sine of x over 2 will be 2 pi over 1 half, which is equal to 4 pi. So that means from 0 to 4 pi, we will see one pattern of the sine function. So which is this one. Now, this is the one pattern, one repeating pattern of the sine function. Now, if y is equal to sine 2x, then b is equal to 2. So if we compute for the period, that's going to be 2 pi over 2, which is equal to pi. So which means that we can see one pattern of the graph from 0 up to pi. So if you notice, when b is equal to 1 half, which is between 0 and 1, the graph of the basic sine function is stretched horizontally. While when b is equal to 2, or when b is higher than 1, then the graph of the basic sine function is shrink horizontally. So that's the effect of the period of the sine and cosine function. So again, the amplitude is for the vertical stretching or vertical shrinking, while period is for horizontal stretching or horizontal shrinking. So let's apply these concepts, these amplitude and period concepts. Let's consider the graph of f of x equals 1 half times sine of 2x. And then this red graph here is the graph of the basic sine function. Now in f of x, the value of a is equal to 1 half and the value of b is equal to 2. So this means that the amplitude is equal to 1 half, while the period is 2 pi over 2, which is equal to pi. So this means that there will be a vertical shrinking of the sine function or of the basic sine function and a horizontal shrinking of the basic sine function. So what will be the labels of the x coordinates of the 5 highlighted points of this particular function? So since the period is pi, then we have to divide pi by 4. So pi divided by 4 is pi over 4. This will be the second, the x-coordinate of the second highlighted point. And the first one will still be x is equal to 0. Now this pi over 4, it will be multiplied by 2 to get the third label. So pi over 4 times 2 is 2 pi over 4. And then pi over 4 will be multiplied by 3, so we get 3 pi over 4. And pi over 4 will be multiplied by 4, so we get pi. So the 5 important points will um, will be plotted at x equals 0, x equals pi over 4, x equals 2 pi over 4 or pi over 2, x equals 3 pi over 4, and x is equal to pi. So which means if we change the color of our graph, it changes to, let's say, green. So at x equals 0, the value of y will be 0. At x is equal to pi over 4, the value of y will be positive 1/2 because the amplitude is 1/2. So this will be a point on the graph of f of x. And then at x is equal to pi over 2, we go back to 0. Now for x is equal to 3 pi over 4, the value of y will be negative 1, which is here. And then when x is equal to pi, the value of y is 0. So connecting these green points by the sine pattern, then we get the graph of 1/2 times sine of 2x. So we see that there's a vertical shrinking of the red graph and a horizontal shrinking of the red graph. Next, this time let's consider the function f of x is equal to 3 times cosine of 1/2 x. In this case, a is equal to 3 while b is equal to 1/2. So the amplitude is 3, or the absolute value of a equals 3, which is 3, and the period is 2 pi over 1/2, which is 4 pi. Now, to get the labels of the 5 important points, of course, we start at 0, and then 4 pi will be divided by 4. So 4 pi over 4 is pi. And then we multiply this by 2 to get the third label. And then we multiply pi by 3 to get the next label. And then we multiply pi by 4 to get the last label. So that means the 5 points should be plotted at x equals 0, pi, 2 pi, 3 pi, and 4 pi. But the amplitude must be 3. So that means the highest value must be positive 3 and the lowest value is negative 3. So plotting these points, so this is the cosine function. So that means at x equals 0, we will have the highest value of y, which is positive 3. When x is equal to pi, we have 0. And then when x is equal to 2 pi, we have the lowest value, which is negative 3. When x is equal to 3 pi, we go back to 0. And when x is equal to 4 pi, we go back to the highest point, which is positive 3. So connecting these 5 green points by the cosine pattern, then this is the graph of 3 times cosine of 1/2 x. So observe that the green graph is a result of a vertical stretching of the red graph, which is the basic cosine function, and it is also a horizontal stretching of the red graph. Next, now this time let's consider the function f of x is equal to negative 2 times sine of 4x. So in this particular example, the value of a is negative 2 and the value of b is equal to 4. So if we get the absolute value of a, it's going to be the amplitude of the graph of this function, while the period is 2 pi over 4, which is pi over 2. So to get the labels, we will divide pi over 2 by 4. So that's going to be pi over 8. But of course, we start at 0, and then we have pi over 8, we multiply this by 2, that's 2 pi over 8, which is pi over 4. Then we multiply pi over 8 by 3, so we get 3 pi over 8. And we multiply pi over 8 by 4, which is pi over 2. Now, since the function has a negative value of a, that means that the graph must be a reflection of the graph of positive 2 times sine 4x along the x-axis. So at x is equal to 0, of course, so if this is the sine function, we begin with the origin. But when x is equal to pi over 8, which is somewhere here, we have to use negative 2 as the value of 1 because it must be reflected along the x-axis. And then when x is equal to pi over 4, we go back to 0. And then when we use 3 pi over 8, which is between pi over 4 and pi over 2, we move to positive 2 or y equals 2. And when x is equal to pi over 2, we go back to 0. So connecting these 5 green points, then we have the graph of negative 2 times sine of 4x. So again, there's a vertical stretching and horizontal shrinking of the graph. And the graph of sine is reflected along the sine, along the x-axis. Okay, next, so since you already know the amplitude and the period, now this time let's apply the horizontal shift to the graph of the sine and cosine function. So first, let's consider the function f of x is equal to a times sine with parameter b times x minus c, and g of x is equal to a times cosine with parameter dx. This should be minus c. So let's change this first to minus c. Let's change this to minus c. There you go. So now we can define the horizontal shift of the function. The horizontal shift of the graph of this function is denoted by the absolute value of the value of c over the value of b. Now, if c is greater than 0, the graph of y equals a times sine dx or y equals a times cosine dx is shifted by the absolute value of c over b units to the right. While if c is negative, the graph of y equals a times sine dx or y equals a times cosine dx is shifted by c over b units going to the left. So let's have an example for this. So let's consider the graph of the function f of x is equal to positive 4 times cosine of 2x minus 5. So in here, the value of a is, oops, the value of a is equal to 4. The value of b is positive 2. Now, since this is bx minus c, that's going to be c is equal to 5. So the value of c is equal to 5. Okay, now, so in this case, the amplitude is 4, while the period is 2 pi over 2, which is pi. Okay, that's correct. 2 pi over 2 is equal to pi. Okay, now, so if we will apply only the amplitude and the period, then we have to divide again this period by 4 to get the labels of the in the x-axis. So we have 0, and then the period pi will be divided by 4. Then this will be multiplied by 2. That's going to be 2 pi over 4. And then this will be multiplied by 3. We get 3 pi over 4. And then this one will be multiplied by 4, which is 5. So that means from 0 to pi, we have one copy of the graph of the cosine function. But there is a vertical stretch up to positive 4 and negative 4 because the amplitude is equal to 4. Okay, so if we will graph that 4 cosine 2x, then that's going to be, uh, there will be a point at positive 4, and then at pi over 4, we have 0. At pi over 2, we have negative 4. At 3 pi over 4, we have 0. And when x is equal to pi, we get positive 4. So this orange graph here is the graph of the cosine function of 4 cosine 2x. However, since there's a minus pi, for 2x, then we have to apply a horizontal shift to the graph, to the orange graph here. So what will be the horizontal shift? So according from the definition earlier, it is C over D, or absolute value of C over D. Now C is positive 5, while the value of D earlier is 2. So that's going to be absolute value of pi over 2, which is pi over 2. So since there will be, since C over D or C is positive, then that means our horizontal shift is to the right side. So that means the 5 points that are plotted on these x values will now be shifted by pi over 2 units to the right. So which means all of these labels here, we have to add pi over 2 to them. Okay, so that's going to be, we have pi over 2, and then pi over 4 plus pi over 2 will be 3 pi over 8. And then 2 pi over 4 is pi over 2. So pi over 2 plus pi over 2 is pi. And then 3 pi over 4 plus pi over 2 is 7 pi over 8. I'm sorry, 5 pi over 8. And then pi plus pi over 2 is 3 pi over 2. So that means the 5 points must be plotted on these x values. Okay, so which means all these 5 points on the orange graph, they will be shifted by pi over 2 units. So if you are going to use another color for that, then that means at x equals pi over 2, at x equals pi over 2, then we have the value of y as positive 4. And then the second point will be plotted at 3 pi over 8. So 3 pi over 8 is between pi over 2 and 3 pi over 4. So that's going to be 0. And then at x equals pi, we have x equals pi, we have negative 4. Let me see first. The pi over 4 plus pi over 2 is, I'm sorry, this should be 3 pi over 4. Okay, sorry for the error. And then this one, 3 pi over 4 plus pi over 2 is 3 pi plus 2 pi is going to be 5 pi over 4. Okay, I'm very sorry for the error. So again, let's adjust to the graph. The 3 pi over 4. For 3 pi over 4, for x equals 3 pi over 4, we have this point here. So let's erase this blue point. And then at x equals pi, we have negative 4. And then at x equals 5 pi over 4, we have, this is 5 pi over 4, 0. And then when x is equal to 3 pi over 2, we have positive 4. So connecting these blue points by the cosine pattern, then that's the graph of 4 times cosine of 2x minus 5. So the blue graph is our final answer for this particular problem. Okay, so this should be changed to the horizontal shift, the application of the horizontal shift. Next, so since you already know the horizontal shift, now let's now apply the vertical shift to the graph of the sine and cosine functions. So let's consider f of x equals b plus a times sine of bx minus c, and g of x is equal to b plus a times cosine of bx minus c. Okay, so now the vertical shift of the graph of these functions. Okay, let me erase this first. The vertical shift of the graph is denoted by d. Now, if d is positive, the graph of y equals a times sine of dx minus c, or y equals a times cosine of dx minus c, is shifted by d units upward. However, if d is less than 0, then the graph of y equals a times sine of bx minus c, or y equals a times cosine of bx minus c, is shifted by d units downward. So let's apply this through an example. Okay, so suppose that we have the function f of x equals 2 times sine of, sorry for that, 2 times sine of 2/3 x plus 5, and then there's a plus 1 outside. So that in that case, the value of a is equal to 2, the value of b is equal to 2/3, the value of c is negative 5 because this is plus 5, and we know that in our general equation form, that should be dx minus c. So that should be 2/3 x minus negative 5. Okay, and then the value of d is positive 1. So in this case, the amplitude is 2, and the period is 2 pi over 2 over 3. So that means it's going to be 3 pi. And that's the period of this particular function. So if 3 pi is the period, that means we start with 0, and then the period 3 pi will be divided by 4. Multiply this by 2, we get 3 pi over 2. Multiply this by 3, we get 9 pi over 4. And multiply this by 4, we get 3 pi. So these are the labels of the 5 points if we just apply the amplitude and the period alone. However, if we will check with the horizontal shift is c over d. So that's going to be absolute value of c over d, which is absolute value of negative 5, over the value of d, which is 2/3. So that's going to be the absolute value of negative 3 pi over 2, or that's 3 pi over 2. But since the value of c is negative, then our horizontal shift must be to the left. So if we are going to shift it to the left, now all these labels that we computed earlier must be subtracted by 3 pi over 2. So we have to subtract 3 pi over 2 to all those labels. Okay, so 0 minus 3 pi over 2 is negative 3 pi over 2. And then 3 pi over 4 minus 3 pi over 2 is equal to, this will be negative 3 pi over 4. So let me check first. Okay, that's correct, negative 3 pi over 4. And then 3 pi over 2 minus 3 pi over 2 is 0. 9 pi over 4 minus 3 pi over 2 is going to be 9 pi minus 6 pi over 4, which is positive 3 pi over 4. And then 3 pi minus 3 pi over 2 will be 6 pi minus 3 pi, which is 3 pi over 2. So these are the labels. If we are going to apply the horizontal shift. So let's apply it first. So if we are going to apply the amplitude and period alone, then we have to see the 5 points on these x values with amplitude equal to 2. So that means at x equals 0, then we have 0. At x is equal to 3 pi over 4, then we should have positive 2. I'm sorry, 3 pi over 4 is here. 3 pi over 4 is here. And then when x is equal to 3 pi over 2, then we have this one is 3 pi over 2. There should be 0 there. And then when x is equal to 9 pi over 4, we should have negative 2. So this one is 9 pi over 4. So there should be negative 2. And then at x is equal to 3 pi, I'm sorry, 9 pi over 2, sorry, 9 pi over 4 is, let me see first. This is 9 pi over 4, and then this is 3 pi. Okay, so connecting these orange points by the sign pattern, so that's the graph of y is equal to 2 times sine of 2/3 x. However, if you are going to apply the graph for the horizontal shift, so we have to move all these 5 orange points by 3 pi over 2 units to the left. So that's why we have these labels here. So at negative 3 pi over 2, we have, where's negative 3 pi over 2? It's here, negative 3 pi over 2. And then this point will be moved to negative 3 pi over 4. And then this point will be moved to 0. And then this point will be moved to positive 3 pi over 4, which is this one. And then the point at 3 pi will be moved to positive 3 pi over 2, which is somewhere here, this one. Okay, so these 5 points will be connected, and that's the graph of 2 times sine of 2/3 x plus 5. But since we have a plus 1, here, then we have to shift this blue graph by 1 unit upward because D is positive. So all the points here, all the 5 points will be shifted by 1 unit upward. So the yellow graph is our final answer. That's the graph of our function. So this ends our video about graphing of sine and cosine function with the application of the amplitude period and the horizontal and vertical shift. So I hope that you learned how to graph them, and I hope that you will subscribe to my channel. Thank you for listening.